Okay, so I start recording. I forgot to start the recording. I introduced myself. I gave some description of my life, my knowledge, and I read the objective of the course. That's not important. Which is important is the requirements. We will write 2 tests. Now you are discussing the time of the tests with other lecturers. Next time, if I forget, remind me to fix the dates of the tests. I'm quite flexible. After 4 lectures and practice, you can write a test. And then we will write a test at the very last lecture of this class of the lecture. And then if you have problem, you don't reach the minimum requirements, then you can repeat the test. If you get at least an average 3 grade, I will offer that grade for colloquium, for the exam. Then we spare time. It's a lot of time to make exams and everything. So it's good. It's a win-win situation if I offer you the grade. The material of the test is practical, the calculation. Nothing else, but of course you will need to know the theory. Yes. There is a bibliography, very nice. I never seen this. I use a Hungarian short note, and also my knowledge, and a lot of other things that I have used. The city is horrible. There is no air condition, and usually the temperature is much lower than right now. Do you have any question about the requirements? If you have any question, do not hesitate to stop me and ask. I'm here for you. You should understand what I do, and it's better if many students pass the test and later will know what I teach. Okay? So don't hesitate to ask if you have any question. I gave you my email. You can write my email. In the subject, write Linux or something like this. Then I can sort it out with an automatic filter. And also I have a lecture time. No lecture. What is the name? Office time. But you cannot see. I still don't have problem with this. Here still. What? That's interesting. This is not here. So this is the time when I'm ready to meet you in my office. My office in the F building. It's 250. It is at the end of the corridor. Okay? So if you have any question, just come, ask. If you don't understand something, I can send you extra material, which is quite difficult. I have to do it in English. And honestly, this is my first class in English. I have given many talks in English and poster presentation and everything, and I work in English, but I never did class in English. But I'm quite happy. Okay. So, yes, let's start. There are quantities. One type of quantity is without direction. A mass. My mass. You know mass. You know temperature. Temperature has no direction. Also a length. Be careful. Only a length has no direction. In English, the speed, not the velocity, the magnitude of the velocity, the speed, also has no direction. So these are quite, these quantities are called scalar quantities. They are not, they don't depend from direction. There are special quantities with direction. My weight, I mean not mass, weight. What is weight? The weight which pushes the surface under you, or if you hang up someone or something, then the rope is pulled by the weight. So that's the weight, it's not the mass. The velocity, it's not the speed. So if I travel from Pécs to Budapest, it's also there is a not location, it's a difference, it's a movement. It also have direction, and yes, and if I give the velocity, it's 100 km per hour, and said from Pécs to Budapest, or from Pécs to, I don't know, Baja, its closest city, or Szekszár, then I have a direction. That's a vector. Be careful, there are very weird vectors. Rotation. If I rotate, I can rotate in this direction, it's anti-clockwise, and clockwise direction. Also, then I have a speed, a rotational speed. The best thing, if you take your right hand and check and do this movement, so your fingers are anti-clockwise, then the rotation's axis, the direction, the vector is given. It is in physics. These are a bit different vectors than the speed, position, and acceleration, deceleration. But it has importance in physics, not here. Here, we just know these are special quantities. Well, if you want to write vectors, you can use just boldface. I do it because that's the simplest for me. You can use underline. If I write on the table, perhaps that's the simplest to me. But if I write in the computer, the boldface is simpler. And of course, you can use an arrow on the top. Okay, I have sometimes I have weird association. Do you know François Villon? He is from the 15th century in France. He was a poet, and he was also a criminal. And this is one related to the weight and hanging. Francis I am, which weights me down, born in Paris, named Poitos town. And with a stretch of rope, my pate will learn for once my arse weight. In Hungarian, it looks much better. In the Hungarian course, I will give this poem in a better stuff. Okay, now I have to ask, where are you from? So which countries are you from? Together, so it's, are you from, so some of you came from Asia, China? Yes? Arab countries? Arabic countries? Okay. And what else? So what? Yes? Russia? Yes? Turkey? Turkey. Okay. Pakistan. Pakistan. What language do you speak? Urdu. Okay. Georgia? Great. Algeria. Okay. Uruguay. Bangladesh. Great. Anyone else? Hungary. Great. I have to ask whether you can follow me. Do you understand me? What I this is my computer. So the question whether you can follow me. It's okay. There are some problems with this course. Hello, good morning. There are some problems with this course. I also learned mathematics, and the real mathematics is quite tough. This is not the most accurate approach that I give you. In my description, I have topics I will give you. Actually, I will upload. Yes, I will have question. So I will give you the of topics and the thematics of this course. It's not the most accurate. You will learn mathematical analysis. You will also learn I planned to come with my ventilator, but I read there will be only 30 degrees Celsius. Finally, I give it up. Okay, so and you will also learn, some of you, the physicists will learn group theory. It's a subset of algebra. The others will learn algebra. It's very useful and very tough. Okay. Question. I'm new. Do you have access to the Moodle? mwdel.pta.hu. Moodle. Can you try it to me and try it? Because I have access, just I don't see my own lecture. Yes?
Is it the e-learning platform?
It's
The e-learning platform?
yes.
I think we registered yesterday.
You registered. And can you see this course and me in this?
We need a code.
That's challenging because I have no access to my own course. So I have to write to someone.
I don't see if
You?
She will check.
I will
Okay, thank you. Okay, so as I told you, I will provide you the record of this course, also my slides, and sometimes practical exercise and lot of things. Yes? Okay. So usually I share it on the Moodle, but I don't have access to the Moodle. I can upload the movies to the YouTube, that's okay, but I don't know how to share the slides. But everything will be figured out very soon, you know. Okay. Yes?
I was saying that, can you also use Microsoft Teams?
Yes. You know, I use usually Linux, but yes, I will use. And how can I use the Teams?
You can, not you, but we can enter our matching code.
Yes, and then so can I share something with with Teams?
You can make a group. You can make a group for the whole class.
I will. Okay, thank you. I will do it. Just remind me if I forget. Okay, for example, sorry.
It's not in the list of physics.
Okay, I will write this down. Moodle. You start the university, I also start the university, so it's not easy. And also after this summer, last week no one was here. Everything was empty, so okay. Yes. Okay, I will do it, and we will do it. Okay, so I gave a definition for vectors, but there are better definitions for vectors, at least two better definitions. From the secondary school, the vectors were treated as a limited length line segments from point A to point B. Start point is A, point A, end point is point B. That's quite simple. I use this arrow for do this. I think it's understandable or not.
Yes.
I don't want to now this is the test. Can you write my horrible handwriting?
Yes.
I always give practice exercise in computer. This is the first time when I lecture, I write something on whiteboard. So, I hope you can read it. If not, tell me. Okay. We have two vectors. Two vectors are equal if you can transfer, shift one vector to the other. That's one definition. Other definition, if the direction and the length of the vector, the two vectors are the same, then two vectors are the same. If you check all vectors that you can transfer to each other, it gives a group. And this group is it forms a group. Oh, what's this? No, not yet. Not yet. Okay. You have scalars. The scalar quantity is one number. If you are in this plane, then it's more difficult. Then you need a pair of numbers. And here, for example, my former mathematical professor would jump out the window because I used a definition, pair. What is a pair? You know what is set? Set, okay. So, if you have A and B, and that means sorry. So this is a set. It contains a set that contains the first element and also the second element. It is not written here. It's not written in the lecture notes, everything. Just if you give an expression, you have to define it. So this is not that course very defined. But you, in this table, for example, if you want to give, for example, the position of one point, then you need two numbers. How far is it from here? And how far is it from here? Do you feel that? It's a pair. If we are in 3 dimension, it's 2 dimension, then we need 3 points. I wrote it down nicer. If a real mathematician, I'm not that, would speak general, very general. So, but I restrict myself for the real numbers. Okay, if you have a Descartes inner cross of multiplication of real numbers, then you get this 2-dimensional vector, and in 3 dimension you need longer multiplication. What we just do, a horrible way. We made we coupled a pair or a triplet of numbers to one quantity. These are the two-dimensional and three-dimensional vectors. Okay, some of you came from former post-Soviet country, some from China. What I'm explaining, is it simple, very simple, or new? So what do you think about this? Please be honest. Excuse me? It's very understandable. It's okay. Just you know, half of this I learned in secondary school, not at the university. I don't know in which level are you. Do you? So if you consider that's for babies, just tell me. I can switch for more difficult approach. Don't worry. Okay? Take some courage until next week. Oh, no, what is going here? Perhaps my computer is hot.
It was the seventh slide.
Yes, I know, thank you. Okay. Now we have these pairs. There is a big step. What these numbers? Usually we use Descartes coordinate system in the class. In the real life we use other coordinate systems, and the coordinate systems has a it is difficult. It could be curved, it could be not free but five-dimensional, and it could be very, very, very different. Okay, so two vectors are equal and only equal if their origocenter representation are the same. What does it mean? It's the same, the length and the direction are the same, but if you take two vectors, A and B, then the A has components, A, 1, 2, 3, B. And when the components are the same, then the two vectors are the same. That's quite simple. Oh, no. Simple, that's okay. Okay, so not easy. Not easy. What I just told, I have a coordinate system in 3 dimensions, x, y, z. When I was in a secondary school, I read a sci-fi about story in a plane world. Do you know it?
I think I know what you mean.
You know. I will check. I didn't check the English. I read in Hungarian. What I wanted to say, there are 0 dimension, 1 dimension, 2 dimension, 3 dimension, and 4 dimension. I cannot draw the 4 dimension. Have you ever tried to programming hypercube or hypersphere? Yes? You know. But do you know what I'm talking about?
Yes.
Okay, great. Perhaps then it's too simple for you, but it doesn't matter. I will accelerate next time. Okay, so if A okay. If I use this signs like it's okay for you, sets and other things. Just sorry, I don't know what level you are right now. Okay. The magnitude of a vector is the following non-zero number. How? Yes, the magnitude, so you take the components. It's like an extended Pythagoras thesis. Take the components and take the square root. Here, I have to tell you something. We are here in an Euclides space, but there are other spaces. For example, there are matrices. You have a set. Take 2 elements. If these 2 elements are the same, then this number is 0. If you take 2 different points, then this number is 1. That space is equivalent with the Euclid space, and it's also a mathematical construction. Ask your mathematical professor in analysis about this. Vertical space, matrix, and so on. This is just a remark. This is very simple right now. There is only one vector which has no direction. It's the null vector, zero vector or null vector. All of the components is 0, and it has no direction. It's okay? When I turn the pages, you will understand why this is important. It looks simple. No. Yet again. Okay, here I have 2 daughters, one 7 years old, almost 8, the other 10. And I also remember for the primary school. Everything that they learn in the primary school, we can use here. We have 2 vectors, A, and that's it. I don't write here. And we have B. My daughters learn how to add together 2 numbers. 3 plus 2. 1, 2, 3, 4, 5. The extension of this, I shift this vector to this position here. It's a parallel shift. Oh, sorry. It's not A, it's B. And now I have it's correct. So I have a new vector, and this is A plus B. This looks childish, but it isn't. So this is the way how you add two vectors. It's like numbers. You can do the same with matrices, quaternions, and other objects. In algebra, you will have very weird groups, sets, and very strange objects. When you are a computer scientist, you will learn objects and classes. Do you know what is object or classes or anything? You know. This is also a type of extension of this. Okay? It's just very simple. We are at the beginning. If I have okay. Next time. I dare not.
You can do that with the remote, I think.
Remote? Oh.
Here.
Where? No, this one is for that one. This is too simple. This is not the United States or Norway, so Norwegia. Or Finland. If you have opportunity to Erasmus, go to Scandinavia. The woman. No, sorry. You just have a long hair. The woman go to Scandinavia for Erasmus or something like this. You will like very nice universities and very strict women. They are leaders, and in a Scandinavian university, they are much more female than here in IT and also in engineering. Okay, that will be difficult. So if I have one vector in representation and then other vector in representation, sorry, I need more coffee. Then the sum of the vector is the sum of the components. That's true, just the next step. If I try to do the same, so I have an E and I have a this is the A and this is the B vector. What I had done here, without any components, I do this shift. That's the B. And this is the, I need some exercise. Okay, that's horrible. I will write it is done in the notes, so you cannot see this But perhaps you understand what I do. I do the operation without coordinates and with coordinates. I will put it in the slides or send you something like this. And also okay. Yes. Yes. I jumped one slide. You remember for primary school, or secondary school, the addition with numbers is commutative. If you have an A number and a B number and add A plus B, then that's B plus A. It's a general feature. It is true for vectors. Not for anything. You will learn vectorial multiplication of two vectors. It's anti-commutative. The order of the result, the magnitude of the result will be the same, but the direction is the opposite. That will be next time. I have no slides for it. Which is important. If you have an A vector and the B vector, and you add the A to the B and to the B to the A, the result is the same. That's the general stuff. It's true for matrices and everything. It's from primary school to secondary school to university and after university. That's true. Also, it is associative. If you have this bracket and you have three vectors, A plus B plus C, and you have a group, in bracket A plus B, that's the same like A plus, in bracket, B plus C. It's true for numbers, true for vectors, true for matrices. With some operation, it won't be true. Also important, this null vector. I told you it's important to have this null vector. Null vector means you have an element that you add to all vector, then you got the same vector. This is simple motives. If you go through operations and more difficult objects, elements, then you will understand it's not so simple. This is the linear algebra, and you will learn algebra. That's much more difficult and much more tough, and the strict definition you will have. Also for this addition, we can define the inverse vector. The inverse means for all vector, you have n vector that you add to the original vector, you get the null element. This is for addition, sum, total. But if the operation is different, if you do multiplication, then the definition is different. It's a general feature. In secondary school, we learned in Hungary principle of doesn't matter. It's a general stuff. Okay, let's go back and learn something else. You have you have a vector. Just a vector. Two vectors. I need a short. Do you know what are the three principles of a word lecture? You write something in the blackboard. You stand that the students cannot see, do not explain the signs, and then you did it quickly. I try not to do this. So, you have this vector. You have a scalar, lambda. You like Greek letters, don't you? Or you will like. Lambda is 2, it's a scalar. Okay, so I said lambda times A. That's very simple. I have a vector, and the length of this vector is double of this one, but the direction is the same. And it's better if I write this here. Okay? So you A, it's a vector. Three dimension, because we like three dimension. We are so three-dimensional chauvinists. There are two-dimensional people or four-dimensional. Well, not really. I also read a book about changing the dimension and the value of the physical constants. And the life does not exist in all time. For example, you know, physicists know the Coulomb potential. There are, and the gravitational potential. That's very good because if you have a spacecraft on orbit or an electron in a very classical view in orbit, then the orbit is stable. But there are only two potential that gives you this stability. One is this 1 per r. The other is x times d. That's the springs, the flexibility. Doesn't matter. Sorry, if you don't understand, no problem. It's for physics. Okay. This is the multiplication of vector with scalars. It's a number. It's okay? What does it mean? You have a coordinate system. You have the same A vector. Okay, cover it. You cannot write it, but it's okay. That's, you know, principles. Okay, this is the A vector. I have the same number, the lambda. That's and oh, sorry. Okay, so in coordinate Descartes representation, we have a vector. The components are A1, A2, A3, and we do the same that I did without coordinate system. It's multiplied by 2, so the components will be twice, lambda times higher than the original vector. That's lambda times A, that's A. It's okay? It's okay?
Yeah.
Okay. Okay, now the difficulties comes. I understand why I have a tap in the institute. I have a tap there. I didn't understand why I have, because of the chocks. We don't use chocks for a wire for decades, but doesn't matter. Okay. Let's use our imagination. I have this multiplication. I just told you lambda is 2, but lambda could be any number, not only number, it could be also other quantity. Where is my 2? Here. Could be any real number. That's okay. Any. First start with 0. What happens if I multiply a vector with 0? With 0. Yes?
It becomes a zero.
Yes. What happens if I multiply with 1? I haven't the definition for the unity vector, but there are vector which length. No, sorry, it's not that one. Just the number is 1. You multiply a vector with 1. What happens?
You will get the same.
Yes. Minus 1.
Opposite direction.
Excellent. And what happens if you multiply a number, the number between 0 and 1?
It's shorter.
Shorten, yes. Larger than 1?
You will get zero.
Okay, so this is the shorten extension, and if you have the minus, the,
Change direction.
yes, take the direction, and also you can shorten. So this is the transformation. That's simple. You will, well. So just mind what has happened in this case. Okay. Great. The scalar multiplication. You can multiply a vector with a scalar or two scalars. If you have two scalars, then the situation is more difficult.
Yeah, but isn't it, if we have two scalars, aren't they associated so that it won't change anything?
This is one feature, yes. This is the first feature. So if you have two scalars, you multiply one scalar, the vector, lambda and mu, that's the mu. Favorite Greek letters of the physicist, omega, nu, alpha, beta, gamma. Or if you multiply lambda, a scalar with another scalar, you calculate the scalar, and then with that scalar you multiply the vector, you got the same. That's quite simple, that's okay. In the next two rows, there is this distributive feature, which is quite funny because there are two. This is quite interesting. First distributive feature, it's, you know this from the numbers. You have A, B, C number. You multiply A with, in bracket, B plus C. Then the result is A times B plus A times C. Here now we have a multiplication, a type of multiplication, because there will be two other type of multiplication. Multiplication of vectors, scalaric and vectoric. So that will be more difficult. You have a sum of A and B vector. You multiply it with one scalar, the lambda, and the result is lambda times A vector plus lambda times B vector. However, in the next line, there is an interesting stuff. You have two scalar, and you add the two scalar in bracket, and you multiply with the vector, and you got this lambda times A plus mu times A. there are two distributive features of this of multiplying scalar, a vector with a scalar. This is, if you go back to numbers, then it's something new. Because the vectors are not numbers, they are more complex objects than numbers. And there will be more such difficulties, you will see. Okay, if you multiply the 0 vector with any vector with the scalar 1, you got the same vector. Okay, yes. Yes. Okay. We can add vectors. We also can subtract vectors. So now, you could not write it. Great. I erase the table, blackboard. Not table, blackboard. Is this visible blackboard or that one? Or
I think it's safe.
it's very bad. So what can I do with this? Normally if I push this, success! Great! I have 2 MSc, 1 BSc and 1 PhD, and I can now use the blackboard or the projector. Great. So, it's the same. Go back to numbers. You have A and B number. If you reach the difference of the A number and the B number, then this difference is the number that you have to give to B to get A. Primary school. You have A and B vector. And you look for the difference of this vector, and this difference is what you add to the B to get A. Simple is the same. Okay, let's draw it. I have an A vector. Somewhere there is a B vector, and I shift in common point. That's the B vector. I'm looking for a vector that I could add the B, get A, and that's it. This is the sorry. I need more coffee. This is the A minus B. I add it to B. I got A. Do you understand my point? I'm not want to explain you very simple things. I want to give you the principle. It's the same with numbers and with vectors. And it will be the same with tensors, with matrices and other objects. It's the same. You should see this curve, so this method. And now, I would need another table. I have another table because I don't have projector. If I use this, as I said, A, and I have the representation also I have B. I should decide whether I use written or printed vectors. Oh, and also can decide something. I can write with my other hands. Which is nicer? I think right is better right now. Where? Okay, what is it? I have a coordinate system. You see that's perpendicular, of course. Three perpendicular lines on plane. Excellent. My daughters are better in drawing, but they don't know so much about vectors. But they ask about sets and vectors and matrices because they saw what test I wrote for my former students. Okay, I have an A vector. I have a B vector. Sorry. And I'm looking for the vector that I could, please help me, I could add to B to get A. This is the A minus B vector, and very simple, you are here, you are jump here, so this is A so I can write what is in the presentation, that A minus B okay. Could you write this down?
Yeah.
This is the same, like subtraction of vector. Okay? I should have write this down, but I had a crazy August, so I just wrote these slides last night. So now we have plenty of time until the end of the class, but this is the end. But I have some question for you. Not question, actually. I just try to go in your head. So I work with Chinese people and also Japanese. And in that culture, if you made a mistake, that's a shame. And you usually hide your mistakes, and you don't ask or you don't do anything. Here, if you have a mistake, no problem. If you try something and fail, you try again, try again, try again. So if I made a mistake, I don't feel shame. If you ask something, you feel it's silly, it isn't actually. I tell you why. Just ask. I always tell to everyone, I was not born with this knowledge. A friend of mine, a classmate of mine, when I learned physics, said always, but in a very, very swearing and vulgar form, that's the nice form. So there is no silly question here. And tell me if I'm too simple, too quick. If you do not understand anything, I'm here for you to learn this. Okay? Not everyone says this, or all classes. If you have any question, then tell me. Have you ever studied at university? Other university? You? No? You? Or you learned university, but others not. Some things are trivial for me. Do you understand what is a test? Yes. The Hungarian name is ZH. It's a closed place. It's a joke actually. Closed place test. I have right to lock the door. I will not. It's just a joke. Do you know what does it mean to get a sign at the end of the lecture, at the end of this lecture period, and denying a signature? Do you know what does it mean? If I deny a signature, then it's not a condition here, then you cannot have a second chance. Then you fail. In the old days, when we didn't have this Bologna and credit answer, then you fail. And you have to repeat the full year again. Do you know what does colloquium means? A colloquium means the exam. That's the Latin name. It's not like you are strict and say what you learn. It's a discussion. In a written form, it's simple to me because you just came and I write this. But when it's oral, then it's a discussion, and I want to know what do you know. It's really a discussion. So I want to know what do you know, what knowledge you build. I do my best to give you slides, record what I have, answer your question. But I'm not a teacher. You are adults. That's a university because there were 7 free arts like medicine, physics, philosophy, blah blah blah. You have to build your knowledge with libraries, internet, asking me, asking here, asking in email. That's okay? I tell you because it's not trivial. What is the name? So the Office of Education, it is an office with humans. Their systems are not good. Sometimes they're lazy. Sometimes they are hot. I mean not hot. They are warm. Hot means something else in English. Be careful. There are organizations of students, and also, did you have this not boot camp, but the camp for the newcomers, for the first year students? Did you participate? Did you have any preparation for this university?
We had the intro for 2 days.
You?
We had the introduction.
Introduction.
Yeah.
Okay. So you know something about this. Okay. What I wanted to say. Look for senior students. Try to gain knowledge. I will give you tests. I will give you homework. I will give you a lot of things. But try to get notes, knowledge about these subjects. In my time, directly I went to senior and asked. But in your time, there are many things in the internet, which is difficult. I'm new, and this is my first time when I studied this, but the linear algebra is quite general, so you will learn more or less the same. Okay, what else? I lived abroad, in different European countries. Even in France, I looked like a Martian. A French woman is 140 centimeters tall. A French guy is 160. So I was a giant. And everyone look at, not with this belly, but everyone look at me. I also was in China. In China, I was really a Martian with my bird and with my big belly. It was later. So I felt horrible. Do you have help to find accommodation, to register yourself and the immigration office, to open bank account? Do you have phone numbers, Hungarian phone number? Do you have these such things?
Yeah.
Do you know whom to ask? It's not my business. Yes?
Yeah.
Okay.
Because we have like mentors.
You have mentors.
Yeah.
There is mentor system in this university.
Yes.
Great. Do you know what is Erasmus?
Yes.
Okay. Do you know that this university is extracted from the Erasmus? You don't know. Hungary is part of the European Union, but there is some problems with the politics of this government, and one punishment was to extract some Hungarian universities from European funds and the Erasmus. The Hungarian government tried to replace it with a Hungarian Erasmus, but it's not the same. Why is it important? If you go to somewhere to work, to apply for a fellowship or an Erasmus, you will need a recommendation. Can the mentor, what is your name?
Mine?
Yes,
Nani.
Nanya.
Nani.
Nani.
Yeah.
Nani, okay. Nani. So, can you ask recommendation from your mentor?
No.
Is it, have you asked this question? Have you?
No, but there are students like us, and they just help us to accommodate in Hungary. So I don't think they can be people.
Yeah, I think recommendations can only come from professors.
Yeah, only.
No. It's more difficult. I don't know the Hungarian system. I'm quite newcomer. I spent most of my time abroad. But in Britain, the mentor means it's a senior student, with graduate student, and then you can ask recommendation from him. The first recommendation. Later you can ask professors. But which professors do you ask? Will I know you after this course to give you a recommendation? No. If you go and come and you will write your BSc thesis or MSc thesis with me, or do you know what is scientific student organization? You know? The others do not know. You know what is it? So if you are interested in science later, you can start right now. You can approach a professor or anyone else, or even outside of the university, and you can do a scientific topic. For example, very simple BSc level physics program. One girl took, with a team of course, built a balloon, put a Geiger-Müller counter. Do you know what is it? It's for radioactivity on it, and launched it, and it reached the stratosphere, something 35 kilometers with the camera. It was nice. Then she had the data and analyzed the data. It's quite simple, but it was a scientific, an independent scientific approach. That girl, I was the viewer. That girl now is in Sweden, the Karolinska Institute. She does the MSc there, but also she did the MSc at the Latoš University. So if you have this thesis, scientific student PTK thesis, then you do not need to write a BSc or MSc thesis. If you are interested in, if you are not interested in, it doesn't matter. But if you are, if I'm the supervisor of such a student, I can give a recommendation. The mentor or a BSc thesis or MSc thesis supervisor could give this one. If you have such a question or anything, you can also ask me, because I lived abroad and now I'm on the other side. And Hungary very often is a very strange place. We are not like normal Western people, Germans or English, British, but there are strange rules here. Some of these rules are familiar because we were under Soviet occupation, so there are some similarities. Also the system, the university system is really similar. Okay? Okay, so I think it is time. What's the time? 24. Okay, so class dismissed. See you next week. And some of you, no, not some of you, all of you will come tomorrow for the practical exercise. Okay, that will be interesting. Okay, see you tomorrow then. Thank you.
For the practical course tomorrow, it clashes with another class.
Oh, you're talking about mechanics?
Yeah.
It's sold, I sold it.
So,
Yeah, Louis will change it.
Okay, great.
I have a question about exam.
Yes.
So you said there will be like 2 tests and exam, or just 2 tests?
If you have 2 tests
Yes.
and you get average grade,
Yeah.
then I will offer you that grade for exam. If you not, or if you get an average and you want excellent
Okay.
or good, then you can come and pass an exam. On the test, you will have practical stuff,
Okay.
and in the exam, you will have theoretical stuff.
Okay.
Oh, wait, I have to switch off the record. I'm listening to you, just yes,
So,
yes,
exams, like tests, will be just practical stuff?
yes, and that's why you must come to the okay, I forgot to tell you something. The general rule, you do not need to attend lectures, but you must, you have to check, but you must attend laboratories and practical exams.
Like, for example, in our other math courses, if we had 3 absence, unexcused absence, even if we have medical issues, we will just have this course again.
Okay, I will ask the secretaries and my colleagues. For me, it's a feedback if you come to my lecture, then my work is good. But some people expect to come. It's better if you come. I try to do my best. So, okay. It is for lectures, not for practice.
Okay. Oh, and one more question. We will know about exam dates when?
Okay,
Or
let
like
me stop this.
1 month earlier or something, maybe.
Okay, so now I switch this off.